Okay, guys. Um, Great job on Unit 4. Very proud of you for all the hard work. Um, One thing in particular I want to talk about is your perseverance in overcoming all of the technical difficulties that we had with all the systems crashing, and you guys just keeping on top of it, emailing, say I can't get in, what can I do to get in? I mean, that shows me that, all of you guys trying to get to the Zoom meeting, emailing me, that shows me that you want to succeed and you want to be successful. I just want to make sure you know how thankful I am for that. So let's start with great job on Unit 4, everybody. Can't wait to grade all those tests because I know they're going to be great. But let's keep that momentum going with Unit 5. Unit 5, I think you'll like this unit. I think you'll like this one. Unit 5 is all about operations with polynomials, working with polynomials, adding, subtracting, multiplying, dividing, composite functions. That's the stuff we're going to get into. This lesson in particular, is focusing on adding, 5.1, adding and subtracting polynomials. Our goal here is to be able to add and subtract polynomials correctly, to understand the notation that's used. We've seen this before, but what's different between this level and what you've seen as juniors and freshmen in algebra is the rigor is going to be increased, and you're going to see some notation that you haven't seen before. Okay? All right. So when you add and subtract polynomials, it's all about combining like terms. Okay? I've got 3 functions real quick. Let's incorporate some vocabulary that we've heard from the past into this lesson to describe these polynomials here. So f of x is a function, right? F of x. Don't be afraid of it. Don't say f times x, right? It's f of x. Say it. F of x. F of x. F of x is equal to 3x squared minus 5x plus 1. That's one function. So what about this? It's got 3 terms. What can we call a function or a polynomial that has 3 terms? Trinomial, right? So we classify it by the largest degree, which is 2. So it's x squared or the exponent of 2 is the largest degree because of this x squared. So we would call it quadratic, okay? We've got another polynomial here. Look, this one's a little bit out of order, right? The x term normally would go before that, but that's okay. We can still add it. I put it up there so that, we'd be careful when we're combining like terms to make sure we carefully look at what can be added. So it's still a trinomial. It's still quadratic. This one here is what we would call in descending order because it goes down from largest degree to smallest. And then we have this one here. It's got 2 terms. 2 terms would be a what kind of nomial? Yeah, a binomial. And we look at the largest exponent. It's 2, so it's also x squared. So pardon me I just wanted to go over some vocabulary real quick that from the past that I might be using today, so that you know what I'm talking about. But okay, so this is all about combining like terms. When we're adding, subtracting polynomials, we combine like terms. So we're going to see some new notation here. We're going to see something that looks like this: f plus g of x. Okay, so what this tells us is we're going to add functions f and g. Like, it's a fancy way to say add this to that. That's all that is. So don't be scared of it. It's new, but it's pretty simple and straightforward. And when you add, I want you to always put, when you add, especially when you subtract, but you should always do it no matter what the operation is, because it's just a good habit. But put the polynomials that you're adding or subtracting in parentheses, okay? If you don't put it, especially when you're subtracting, it will come out wrong. So we're going to add the f function to the g function, which is 3x squared minus 5x plus 1. And we're going to add that, and I'm going to put it in parentheses, to x squared minus 3 minus 2x, okay? So when I add 3x squared to x squared, I get 4x squared. Okay, and sometimes what is a good habit too, this one's not a terribly big, this is like a spice level 2 right here, spice level 1. But when we get up to spice level 9, a good habit is to cross them out as you go so that you don't miss a term or you don't count a term twice on accident. But it's just another way to help you stay organized. So negative 5x plus negative 2x would be negative 7x. So I'll cancel those out. And then 1 minus 3. 1 minus 3 would be negative 2. What do you think? Pretty straightforward? All right, I want to do 1 subtraction 1 together, okay? You got this one down in your notes? I want to do 1 subtraction 1 together, and then we're gonna let you try a spice level 5 on your own. All right. So let's do, what do you say we do h of x, ooh, no, that's not how it would be written. It would be written like this, h minus g of x. So tell me, what does this notation tell me to do? What is it asking me to do? Yeah. We're gonna take the h function, we're gonna subtract the g function in it. Do we need parentheses? Yeah, we do. So we're gonna go 3 minus 9x squared, because that's the h function, right? And we're gonna subtract the g function, which is x squared minus 3 minus 2x. Okay, so subtraction is tough, guys. I mean, it's much harder than addition. It's much harder. But every addition can be done or turned into, I'm sorry, let me just try to speak again. Every subtraction problem can be turned into addition by adding the opposite. And I hope that you'll do that. I really do. I started doing it at a young age. I had a great teacher in elementary school. Had me start doing it. I've done it ever since. And I wish you would all start doing it. So instead of subtracting all these, what we're going to do is we're going to change it to add. Use a different color so you can see my changes. And then we'll change the sign of every single one of these. So this becomes negative x squared. This becomes positive 3. And this becomes positive 2x. So instead of subtracting, I'm adding the opposite. All right, now it's just addition. Look, 3 plus 3, that's too easy. I'm going to cross those out. 3 plus 3 is 6. I have a negative 9x squared plus a negative x squared. Negative 9x squared plus 1 more negative x squared is negative 10x squared. So that takes care of my x squared terms. And then the only thing I have left is plus 2x. So I have plus 2x. I hope you will use adding the opposite. I really do. I know sometimes you get stuck in the ways. You know what? And if they work for you and you're doing great, then fine. I'm not going to ask you to do it, but I don't know. For me, it's always worked out better to add the opposite. Subtracting negatives can get confusing. Adding them is much more clear. All right, now, so this is a fine answer, but you may, on your Math Excel homework, be asked to put it in descending order. So let's put it in descending order. So let's, the largest exponent is 2, so we'll go negative 10x squared, and then we'll keep the sign of it, and then plus 2x and plus 6, and that would be our answer there. Okay, now, I want you to try one on your own. I'm gonna erase this here. There you go. Are you ready? Let's do h of x. No, that's not how it'd be written. It'll be written like this. H minus f minus g of x. I bumped it up to a spice level 6 right here, right now. Spice level 6 right here, right now. First off, tell me what it means, okay? Well, what it means is, let's see, you write it down, and we're back. What it means is to take the 3 minus 9x squared, which is the h function, right? And we put it in parentheses, right? And we're gonna subtract the f function, which is 3x squared minus 5x plus 1, all right? And from there, we're gonna subtract the g function, which is x squared minus 3 minus 2x. All right, what do you think? You with me so far? Okay, now take a minute, see if you can figure it out on your own. Put some answers in the chat. Let's see what you're getting. I want to know what you're getting. All right, we're back. Now, let's start with the x squared. So I'm going to underline and cross them out as we go to keep myself organized. So I have a negative 9x squared. Oh wait, hold on. Before I do anything, I want to add the opposite, guys. I want to add the opposite. So I'm going to make this plus, change this to negative, this to positive, and this to negative. Okay? I'm going to make this plus. I'm going to turn this to negative, this to positive, and this to positive. So I changed it to addition, and I changed the sign of everything. Now you can do it with the same color. I just did it with the red marker so you can see my changes there. All right, so I have a negative 9x squared plus a negative 3x squared. That's going to give me negative 12x squared so far. Plus a negative x squared, that's going to give me negative 13x squared. Boom. That takes care of my x squared terms. Now let's do my x terms. This does not have any x terms. This has a positive 5x plus a positive 2x. So that would be plus 7x, right? Now I have a positive 3 plus a negative 1, so that's positive 2, plus a positive 3, which gives me a plus 5. All right, so this is our final answer, and we're in descending order. We love everything about this answer here. Hopefully you got it. Great job if you did. One more example. I'm going to put this one up. Let's see what we can do. I went through for this particular example, and I selected from our book the most difficult one I could find, because I know what you guys can do. We're going to get away from the notation just a bit. I'm not going to talk about the notation. I'm just going to present the two polynomials that you guys are going to add together. I went through, like I said, and I found the hardest problem for this topic, adding and subtracting polynomials, in this book. I want all of you to try it. I want none of you to be afraid of it. But here we go. Let's go. Let's go. 2z squared minus 3x plus m plus z squared minus 2m. All right, so that, and we're going to subtract from that minus negative 4x plus 2z squared plus 3m. Okay, so first thing, I do not want you to be afraid of these brackets here, okay? All the time the students are afraid of brackets. Don't be. Really, they're just a form of organization. Let's see what the brackets do. See this opening rounded parentheses here? It's rounded to tell you that it matches with this closing rounded one. This one's rounded to tell you it matches with this one. This bracket, the book, the author of the textbook is trying to be nice because he thinks that if you have too many soft rounded ones, that you'll get them mixed up and you won't know which one it goes with. So this bracket helps you go with this one, but it's nothing more than a way of helping you group these terms efficiently and effectively, but students seem to get scared by them, but don't. So I want you to try this one on your own. Let's see what we can do. Give you a second here. And we're back. All right, so I'm gonna work within these parentheses first and combine anything in here that I can. I can combine the 2z squared and the z squared, and that gives me 3z squared, okay? I have a negative 3x. I have an m plus a negative 2m, that's gonna give me a negative m. combining all that, I got this trinomial here. All right, I see minus, guys. So what that means is we're gonna add the opposite. So this is gonna become add, this will become add, this will become minus, this will become minus. Okay, so I'm gonna write that next to here, nice and clean here. So it's gonna be plus positive 4x minus 2z squared minus 3m. Okay. Now I can combine everything. I have a positive 3z squared plus a negative 2z squared, so that's going to give me z squared. I have a negative 3x plus a 4x. That's going to give me x. I have a negative m minus or plus a negative 3m. That's going to give you negative 4m. It's easy as pineapple cake upside down. Thank you guys so much. I hope I'm proud of you. I'm just kidding. Hold on, this smudge here. It's positive z squared. Okay. Thank you guys so much. I appreciate it. Great start to Unit 5. See you in the next video.